Hello and welcome back to my series of videos and narrative on the science of evolution. My name is Tony B and this episode looks at a very hot subject indeed, igneous rock. My previous video looked at sedimentary rock and the evidence that it provides for deep time. I am continuing this strand of looking at the evidence for deep time with facts about igneous rock and how this rock and the geological science that supports evolution simply does not support the creationist perspective. Before we get to igneous rock, I would like to first mention three of our most reliable sources of information and evidence regarding the geology of our planet and its age. Zircon crystals, meteorites, and lunar rocks. I will be dealing with the use and process of scientific dating methods in another video, but right now I just want to touch on these sources of information which feed into this video on igneous rocks. I will be looking at all three sources of evidence within this video, but let us start with zircon crystals. Zircon crystals are the oldest material found on Earth. They have allowed us to date the age of the Earth, and they show that the age of the earliest crust is 4.4 billion years. In respect of zircon crystals, I can reliably state that uranium-lead dating was used to determine age, and that zircon is the most common material used for this dating method. It has proved to be nature's best clock. Why? It is resistant to mechanical weathering, which is the process of big rocks breaking into small ones, and chemical weathering, which is the erosion of rocks caused by chemical reactions. It is also resistant to metamorphism, which is when heat or pressure cause a rock to change its composition or structure. Zircon is commonly found as the primary material in igneous rocks, since igneous rocks have no fossils. This makes zircon valuable in dating them. I will return to the subject of lunar rocks and meteorites, in particular the Alande meteorite, later in this video. But for now, I just wanted to get us started with a very important mineral in respect of igneous rocks, zircon. As stated in my previous video on sedimentary rocks, James Hutton is regarded as the father of modern geology. He was an early proponent of uniformitarianism, the science which explains features of the Earth's crust by means of natural processes over long geological timescales. It was in the summer of 1785 at Glentilt in the Cairngorm Mountains in the Scottish Highlands that Hutton found granite penetrating metamorphic schists in a way which indicated that the granite had been melted at the time. This demonstrated to Hutton that granite formed from the cooling of molten rock rather than it precipitating out of water as others at the time believed, and therefore the granite must be younger than the schists. From this point on, Hutton discovered other examples of this process which supported the evidence that a great flood had not created the Earth as we view it today. James Hutton promoted the theory of Platonism. His contemporary, Abraham Werner, took the side of the Bible and promoted the Neptunist theory. This supported the Bible and was the accepted understanding of geology in the 18th century, that all rocks had precipitated out of a single enormous flood. Due to his observations, Hutton proposed that the interior of the Earth was hot, and that this heat was the engine which drove the creation of new rocks. He proposed that land was then eroded by air and water and deposited as layers in the sea. Heat then consolidated the sediment into stone and uplifted it into new lands. This theory was dubbed Platonism. It was in contradiction to the flood myth. Hutton's main argument based on his observations that the Earth was older than the 6,000 years proposed by the Church, was that the tremendous displacements and change he was seeing did not happen in a short period of time by means of a catastrophe, but that the process was still happening on the Earth in the present day. As these processes were very gradual, the Earth had to be ancient to allow time for the changes to occur. So, let us now start to look at those processes that Hutton observed and predicted, and why igneous rock does not support a 6,000-year-old universe. Igneous comes from the Latin for fire, and that is an apt description, as it is forged from the heat of the earth. It is one of the three main rock types: sedimentary, metamorphic, and igneous. It is created via the cooling and solidification of magma or lava. Magma is formed below the surface. It is molten or semi-molten, and it is the natural material from which all igneous rocks are formed. Lava is what is created above the surface of the earth. Therefore, magma is described as intrusive rock and lava as extrusive rock. Remember how James Hutton made observations of granite formations? Well, granite is an intrusive igneous rock formed from magma that flows and solidifies underground, where it cools slowly, very slowly. Evidence supports the concept that all granites are not formed at the same time as other rocks, which they are adjacent, and that some granite bodies are younger in age than other granites. The fact that granite bodies intrude other rocks by filling in cracks, for example, to form dikes, indicates that other rocks are older than the granite, that at one point in their history they were molten, and this supports Hutton's observations and conclusions in the 18th century. Which brings us to the issue of heat and the creation of those granite formations Hutton observed in the 18th century. Blocks of granite are very poor conductors of heat. If a body of granite magma had a surface area of 30 to 50 square kilometers and a depth of 20 to 35 kilometers, the total amount of heat stored in such a granite mass at a temperature of 900 degrees centigrade is enormous. Calculations show that such a volume of granite magma would take several million years to cool down from 900 degrees centigrade to nearer 500 degrees, where it would totally crystallize, and then finally to cool to the 25 degrees centigrade found at the Earth's surface. Further evidence for the time this process takes can be found at the COSO range of East Central California, where slow cooling is indicated by deeply buried granite magma still giving off heat. It contains rhyolite flows, which is the volcanic equivalent of granite. The residual heat is being utilized for steam generation and electrical energy. We have looked at how long it takes for magma in respect of granite to cool. At the point of crystallization, granite, like all intrusive rocks, becomes granular. As previously stated, lava produces extrusive rocks at the surface. These are without crystallization and form natural glasses. An example would be obsidian. Basalt is the most common of extrusive rocks. Such rocks are fine-grained, aphanitic, or even glassy. Some kinds form long polygonal columns. The Giant's Causeway in Antrim, Northern Ireland, is an example. Rich in magnesium and iron, more than 90% of all volcanic rock on Earth is basalt. It is a common rock on the surface of Mars. On the Moon, the lunar maria are plains of flood basaltic lava flows. So, in respect of igneous rocks, here are a few fun facts. It makes up 90 to 95% of the top 16 kilometers of the Earth's crust by volume. It forms 15% of the Earth's current land surface. Most of the Earth's oceanic crust is made of igneous rocks. And igneous rocks can provide mineral deposits that host materials such as tin and uranium. Just to recap, we now know about the differences between intrusive and extrusive rocks. We have a better understanding of how long it takes intrusive rocks, such as granite, to cool. And we have a better understanding of how geologists, such as James Hutton, helped increase our understanding of the natural processes in geology that we have so far studied. But what about that process? Let's have a closer look. Magma is the material that all igneous rocks are formed from. You might remember that when it exits the Earth, it becomes lava. It becomes extrusive rocks, such as basalt. Below the crust from which the magma exits, we come to the mantle. The mantle is the layer inside a planetary body, bounded below by the core and above by the crust. The mantle is the largest, most massive layer of the planetary body. The mantle is a layer of silicate rock. Silicate is a wide variety of compounds that share a silicon and oxygen structure. Silicate minerals are the largest and most important class of minerals. They make up 90% of the Earth's crust. This image represents some examples of silicate minerals, from quartz to mica. The layer of silicate rock is predominantly solid, but in geological time behaves as a viscous fluid. Remember when we started this video, we looked at zircon. Well, zircon is a silicate mineral. In geology, silicate is used to mean silicate minerals, ionic solids with silicate anions. What we know now, as opposed to what we knew in the 18th century about the interior of our planet in respect of its composition and the natural processes at work, help us to understand its history and its original formation. When forming, it would have been entirely molten, not solid. This was due to the release of gravitational energy. At this time, the Earth became chemically differentiated. In its molten state, it contained many elements. Heavy elements, notably iron, sank to the center to form a core. Light elements remained in the mantle and crust. We know that the heavy element iron gives us the solid inner core of our planet. It has a radius of about 760 miles. It is surrounded by a liquid outer core composed of a nickel and iron alloy. This causes the Earth's magnetic field. Information about Earth's inner core comes from our analysis of seismic waves and Earth's magnetic field. Remember, James Hutton believed the Earth had a hot inner core? Well, now we can confirm Hutton was right. The temperature at the inner core surface is estimated to be approximately 9,800 degrees Fahrenheit, about the same temperature as the surface of the Sun. With what we have learnt so far about sedimentary rocks in my previous video and igneous rocks in this video, what does the science tell us about deep time and the creationist model? So, let us quickly recap. Initially, the Earth did not have a crust, mantle and core, and instead all the elements were evenly mixed. no oceans, no continents, no atmosphere. Meteorite collisions, radioactive decay and planetary compression made the Earth hotter and hotter. It took hundreds of millions of years for the temperature to reach 2000 degrees centigrade, the melting point of iron, and from this point the Earth's core was formed. Much of the Earth was molten. There may have been a magma ocean at the surface. Gradually, the Earth cooled and a core, mantle and crust was formed. When the Earth was entirely molten, gravity drew denser elements to the center and lighter elements rose to the surface. The separation of Earth into layers based on density is known as differentiation. The densest material, i.e. iron, moved to the center to create the planet's dense metallic core. William Thomson, also known as Lord Kelvin, was a British mathematical physicist and engineer. He completed important work in the mathematical analysis of electricity and the formulation of the first and second laws of thermodynamics. During the late 19th century, he accepted that James Hutton's assessments that the Earth had originally been molten as correct. Therefore, using average melting point of rocks and the laws of thermodynamics, he determined that the Earth would completely solidify within 20 million years. Although his calculations have since been proved wrong, at least he was beyond the 6,000 years proposed by religious individuals. Lord Kelvin was leaving out vital information from his equations. Lord Kelvin did not know that the new heat is generated inside the Earth by radioactive decay, nuclear fission, because the process had not yet been discovered. The discovery of radioactivity by Becquerel and Curie led the way to Ernest Rutherford in the 20th century and radioactive dating, which in turn led to the work of Arthur Holmes. Arthur Holmes applied the concept of radiometric dating to rocks. After a century of applying the method, we now know that the oldest known Earth rocks are over 4 billion years of age. In respect of radiometric dating, when we radiometrically date a mineral grain, we are determining when it crystallized. Thus, we would like to use rocks whose crystals are roughly the same age. The easiest are igneous rocks, in which all crystals are roughly the same age, having solidified at about the same time. As stated, I will be looking in more detail at dating methods in another video. Remember at the start of this video, I said there were three main areas of evidence for deep time in respect of igneous rocks, and we touched on zircon crystals. Well, another area is meteorites. Meteorites are the remnants of the original pool that formed our planet. In fact, all planets. They help form the components of our planet through the process of accretion. They impacted our Earth during its formation. Remember when looking at igneous rocks on Earth, we looked at their structure. Well, there are three main categorizations of meteorites, and they contain materials you might be familiar with in respect of igneous rocks. There are stony meteorites, rocks composed of silicate minerals, iron meteorites, composed of metallic iron nickel, stony iron meteorites. They contain large amounts of both metallic and rocky material. Contrary to what young Earth creationists believe, about 5 billion years ago, our solar system was just a huge cloud of dust and gas. Dust particles stuck together, crashed into each other, and began forming bigger clumps, When the clumps became a certain size, their gravity began to attract other material, until we eventually came to the formation of our planets. These small amounts of material left over made up the asteroids. Meteorites are part of asteroids that break off and eventually make it to the surface of Earth. For this reason, meteorites represent some of the original diverse materials that formed planets billions of years ago. Studying meteorites help us to understand the age, composition of different planetary building blocks, and the temperature at the surface and interior of asteroids. Meteorites help us to understand the processes taking place deep inside our planet. We know from studying the chemistry of meteorites that Earth has a core made of nickel and iron metal. Some meteorites are called carbonaceous chondrites. These are made of lots of carbon, the same stuff that makes up most organic compounds, including the backbone of DNA. But that's another story for another day. Suffice to say that dating these rocks help us to establish the age of our Earth. The age of the Earth and the Moon and of meteorites are measured by the decay of long-lived radioactive isotopes of elements that occur naturally in rocks and minerals. And this is something else that I will be looking at in another video that deals with the dating of rocks. In respect of the formation of the Moon, the most widely accepted theory is that of a giant impact. The Moon formed during a collision between the Earth and another small planet. The debris from the impact collected in an orbit around the Earth to form the Moon. Unlike the Earth, the Moon has not changed much since it formed. Therefore, in many ways, it is like a time capsule. The Earth and the Moon are made of similar base materials, suggesting they were created from the same source material. Some moon rocks have been ejected naturally from the surface and fell to Earth as lunar meteorites. Studying these rocks and those returned from the Apollo missions, scientists have noted that in some regards, lunar rocks are closely related to Earth rocks in their isotopic composition of the element oxygen. The Earth is a gigantic recycling machine. There is wind, rain, and ice that weather the rocks away. The crust of the planet is dynamic. Continents float, move, and change. Rocks are recycled, remelted, and reformed as continents smash into one another. The Moon, on the other hand, does not erase its history. Aside from asteroid impacts, the Moon has not changed much since its formation. That makes it a time capsule and something worth studying in respect of understanding the geology of our planet. Almost all of the rocks at the lunar surface are igneous. They are formed from the cooling of lava. There is an abundance of basalt on the surface of the Moon. As previously stated, I will be looking at dating methods in another video. However, for now, I would like to state that in the early 20th century, scientists refined the process of radioactive elements decaying into other elements at a predictable rate. By examining the existing elements, scientists can calculate the initial quantity of a radioactive element and thus how long it took for the elements to decay, allowing them to determine the age of the rock. By dating rocks in Earth's ever-changing crust and then comparing them to rocks on the Moon and the visiting meteorites, scientists have calculated the Earth is 4.5 billion years old, with an error range of 50 million years. By doing this, they have not limited themselves to one source of evidence. Comparisons confirm the evidence. I started this video on igneous rocks and the evidence for deep time by looking at zircon crystals. Well, the oldest mineral grains on Earth are from Australia. These tiny zirconium silicate crystals have ages that reach 4.3 billion years, making them the oldest materials found on Earth. Their source rocks have not yet been found. The zircons set a lower limit on the age of the Earth of 4.3 billion years because the planet itself must be older than anything that lies on its surface. Just before we get into summing up the evidence for deep time in relation to igneous rocks, I just want to take a quick look at a place you are all familiar with that provides further evidence: the islands of Hawaii. The Hawaiian Islands in the Pacific Ocean are exposed peaks of a great undersea mountain range known as the Hawaiian Emperor Seamount Chain, formed by volcanic activity over a hot spot in the Earth's mantle. Hawaii is made up of primarily igneous rocks. To date the age of this archipelago, scientists used potassium-argon methods. The oldest island is dated at 28 million years. Geologists have concluded that the crust of the Pacific Ocean is moving at a rate of about 10 centimeters, which is 4 inches per year over the hotspot, or about 1 meter per decade. The highest above ocean peak is almost 14,000 feet. Unless the laws of geology were different 6,000 years ago, then this rate of growth and movement far exceeds the 6,000-year young Earth proposition. Mount Everest is the tallest mountain above sea level, but in respect of height, base to summit, then the tallest mountain is Mauna Kea, an island of Hawaii. Everest stands at 29,035 feet. Mauna Kea is 13,796 feet above sea level. However, the mountain extends about 19,700 feet below the Pacific Ocean. Half of it is submerged. The total height is actually 33,500 feet, nearly a mile taller than Everest. Was this enormous mountain formed 6,000 years ago? Well, only if you believe in magic. It is estimated to be about 1 million years of age. These estimations are based on what we know regarding plate tectonic movements and the creation of volcanic mountains. The age of the Hawaiian Islands is based on observations of current movements of the Pacific Ocean crust by geologists and on dating methods applied such as potassium-argon. None of this scientific evidence supports that this mountain was created 6,000 years ago. So, as is normal for my videos, let us now sum up the evidence for igneous rocks, showing us that deep time is a fact. James Hutton in the 18th century was the first to recognize that granite was once molten. He recognized that granite demonstrated evidence of a subterranean heat, that the granite at the surface was once deep inside the earth and was molten. Scientists class granite as an intrusive igneous rock. Such rocks have a coarse grained texture. The individual grains grow to a relatively large size, but this takes time. It is a scientific fact that the natural process of granite cooling, solidifying and crystallizing takes a lot of time. Granite magma with a surface area of 30 to 50 square kilometers and a depth of 25 to 35 kilometers with a temperature of 900 degrees centigrade would take several million years to cool to 550 degrees centigrade. It would be at this point that it would crystallize. We find granite at 25 degrees centigrade at the Earth's surface. And yet, the fact that granite intrudes other rocks, filling in cracks, forming dikes, we know that the other rocks are actually older than the granite. Remember the work of Lord Kelvin in trying to date the age of the Earth? Well, he used the melting point of rocks and the second law of thermodynamics, and even though his calculations were incorrect, he still managed to give the age of the Earth in millions of years, rather than 6,000. He simply did not know about radioactive decay. How might young Earth creationists explain the issue of granite? To create large areas of granite within just a few thousand years. In the short time young Earth creationists need for their model, they would need to accelerate the accepted process. This would mean the release of gravitational energy that would produce enough heat to melt the Earth's crust and vaporize the Earth's oceans. Without the intervention of magic and a supernatural being, the cooling and solidification of granite is a problem for young Earth creationists. And now you know why we do not find fossils in igneous rocks, only in sedimentary rocks. The immense heat, cooling, and solidification required to create igneous rocks means any fossil would be vaporized. A wonderful piece of evidence for deep time is, of course, radiometric dating, which I'll be covering in detail in another video. As for now, we know that much of the heat generated within the Earth is due to radioactive decay, known as nuclear fission. We know about the process in which radioactive elements decay into other elements at a predictable rate. Radioactive materials decay at known rates, measured as a unit called a half-life. The half-life in a radioactive substance is the amount of time it takes for half of the parent atoms to decay. In respect of radiometric dating, when we radiometrically date a mineral grain, we are determining when it crystallized. Please refer back to the cooling and solidification process of igneous rocks. The easiest rocks to date are igneous rocks, in which all crystals are roughly the same age, having solidified at about the same time. Understanding the natural processes of intrusive rock formation deep within the Earth interior, and then having a scientific system in which to measure radioactive decay and therefore establish the age of materials, helps scientists establish the age of minerals such as zircon crystals, which provide confirmation for the vast timescale of Earth history. And we have been able to cross-reference this research with other data collected from meteorites and even lunar rocks, which have not been subject to the same recycling process as Earth. All the data collected supports each other in respect of evidence for deep time. In summing up the evidence that igneous rocks provide for deep time, we can include the facts that James Hutton was correct in stating that the Earth has a hot inner core, and in doing so he proved the biblical perspective wrong. From Lord Kelvin to radiometric dating, scientists have dated igneous rocks and found that the Earth is not 6,000 years of age. Scientists have studied how igneous rocks such as granite cool and solidify. It takes millions of years. Creationists cannot provide an answer to this heat problem without invoking magic or a suspension of the laws of physics. Their model of how the Earth was created contradicts the scientific explanation of how the Earth was formed. Scientists are able to cross-compare their research on Earth's igneous rocks with meteorites and moon rocks to establish age and the inner workings of our planet. everything from the igneous basalt surface of the moon to zircon crystals on Earth, from the formation of the volcanic igneous rock islands of Hawaii to meteorites, help us to understand igneous rocks, cycles of formation, and the age of our planet. Creationists will continue to ignore or attempt to explain away information on igneous rocks such as granite that contradict their religious views. Science cannot be selective in respect of choosing only the data that fits their model and discarding everything else. If they did, then none of their peer-reviewed papers would be accepted by the scientific community. For example, one can teach rapid formation of granite to fit a pre-flood myth, but it is not teaching science. Among the evidence provided in this video in respect of deep time in relation to what we know about igneous rocks is the cooling, solidification and crystallization of igneous rocks from magma. The observable natural processes and mathematical calculations in the creation of the volcanic islands of Hawaii. Radiometric dating of materials such as zircon crystals, and the cross-comparison supporting evidence with lunar rocks and meteorites. Thank you for taking the time to watch this video on igneous rocks. If you have not yet watched the video that preceded this one, which was on the subject of sedimentary rock, then please check out my Buzzbait videos where you will find it. My next subject will be the various dating methods scientists use to date igneous rocks and fossils. The information provided will support the evidence that I have included in this video on igneous rocks and my previous video on sedimentary rocks. Until then, please take care of yourselves. Goodbye.